and you guys will get going.
Do I just start on my own?
Sure. Are you cool with this being taped and put on YouTube?
Yeah. Okay.
And then when you have 5 minutes, I'll stand next to the camera and we'll just say 5 minutes.
Awesome. All right. So half the audience just left. Open source software is in every computer, in every phone, in every home, in every enterprise that we interface with today. I am completely willing to bet at least a handful of chocolates on that. And that's a problem when it comes to updating and servicing all of that software, because what is that update mechanism exactly? How do you know you need to update Freetype in your daughter's American Girl Xbox game? Oh, that's right, you don't have any control over that, but developers do, and InfoSec people do, and that's what we're here to talk about today. I'm Kymberlee Price. I'm the open source security management lead for Microsoft Security Response Center. I am back at Microsoft after a 7-year break away at some startups and working at BlackBerry. And BlackBerry, woo! BlackBerry is where I first developed PTSD over open source software, and I survived it. So I have been based in Seattle for a very long time, so I did actually bring some Seattle chocolates. It's not as good as Texan barbecue, but, you know, we work with what we have. And I thought maybe since I'm in an after-lunch slot, people wouldn't mind to pick me up. So feel free, grab yourself a chocolate. I will not be upset if you move around while I talk. So I'm not going to do a whole lot of agenda, who I am, all of that stuff. I am on the ACOD content review board, so really appreciate you coming today, appreciate the speakers, and by all means, please do provide feedback after the event so that we can continue to be sure we're providing quality content every year. So, about me. I'm on a number of content review boards. I work at Microsoft. I am lawful good. I'm a behavioral psychologist, and I'm here to tell you why development realities and a level of developer empathy is necessary when it comes to securing open source. Developers are using open source because they have to decide, do I want it cheap, fast, or good? Pick two. Oh. Sorry, I'm used to having a clicker. You can only pick two. You don't get all three. And so open source gives them the ability to do that. They've got deadlines to meet and features to ship and stuff to get out, and they're building the new thing, and what they're forgetting is that they're now an IT admin. They have to install updates. They've got patch management as part of the development lifecycle. And while in DevOps this may not sound completely foreign, there are still people working in, crazy, I know, waterfall development environments where they only ship every 6 to 12 months. They're not shipping every day. And they have to install updates potentially more frequently than they're shipping product. Now, I'm going to run through a few slides just because memory lane is a lot of fun. I expect you're all familiar with this, but the other reason these slides are in the presentation is if you grab this presentation off the internet to show to some of your engineering partners, they won't be familiar with these things. So we all remember Heartbleed because that got our attention. Parents were asking their kids in InfoSec, honey, do I need to be worried about Heartbleed? Mom, you don't even know what a browser is. Dad, you're not even sure where the power button on the laptop is. Don't worry about it. You're fine. Just install the Windows updates. You'll be good. There was Freak. I thought it should be called Super Freak, but I'm weird. And then there was Ghost. Oh, wait a minute. Spectre and wait a minute. Those were Intel. That's not open source. Except you needed browser mitigations in Chromium and WebKit. Did your applications that use Chromium and WebKit, did you think about those when you were dealing with Spectre? Meltdown. Okay, I have typo issues. Sorry. But it's not just named fancy vulnerabilities. Attackers are also finding vulnerabilities every day that don't get a name. Unfortunately, those names get associated with who gets breached by them because Equifax has become synonymous with struts. And the sad thing is, this article about a struts flaw came out a week before anyone heard about Equifax being breached. And the CEO who stepped down from Equifax as a result of the breach blamed it on one guy in IT not actioning an email. My argument is the problem is way beyond one guy actioning an email. The problem is that was your action plan. Your action plan didn't involve a whole lot of automation and systems with, automated work items and detection and alerting. You relied on one guy reading the right email, finding all the hosts, and doing all the right things. So, this is a really fast overview, and everything in open source is broken. And I'm going to actually show some data to support that. But beyond it being broken, we've got attackers compromising the integrity of the packages completely. Why have an O-Day if you can just compromise the package and a developer may not notice that they've installed malware? This happened in NPM, PyPy. So there's multiple attack vectors for open source. So we're gonna talk about some vulnerabilities, and we're gonna spend the majority of the presentation talking about what the hell do we do about this? So when it comes to, let's talk about the two I already talked about, Heartbleed, which is OpenSSL, and struts. If you look at their vulnerability counts, their CVEs, by year, okay, that's a lot of vulnerabilities. So what? Well, that means you got to update them regularly. Heartbleed, since that happened, there have been 100 more vulnerabilities, some of them with a CVSS 10.0. We didn't just fix OpenSSL at Heartbleed. We had to keep patching it regularly. And that's true of all of these libraries. And rebuilding everything that was built with that library, because now we're getting into dependencies. So, hey, Freetype, what happened? Did Freetype get more secure in 2016? No, they just stopped assigning CVEs unless Google Project Zero reported it. They still fix remote code execution vulnerabilities due to malformed fonts. They just treat them like any other bug. Ffmpeg. Ffmpeg is honest and open about the fact that they patch vulnerabilities without documenting CVEs. So their counts are looking better recently, but that might just be because they're being silently patched. Chromium. Chromium looks terrible, doesn't it? Chromium actually patches frequently, and they do an excellent job of documentation, and Chromium uses Freetype and Ffmpeg. So Chromium, because they have a very mature and serious security team, when they release their updates, they also document the Ffmpeg vulnerabilities. They document the Freetype vulnerabilities. They document the zlib vulnerabilities, the libuv vulnerabilities. Anything that is used in Chromium gets documented, which is not the case in every open source library. And then we've got Electron. And I built this slide before the RCE that got patched recently, so add one for 2018. But Electron looks super secure, doesn't it? No. Let's look at it on a side-by-side, because if you're a data nerd like I am, you've noticed that the axes are not standardized here. So that's what it looks like when you put it all together into one slide. And Chromium looks pretty bad. But keep in mind, Chromium is including all those Ffmpeg and Freetype vulnerabilities, as well as some others. And Electron looks really good. So if you're assessing open source to use in your software, Electron seems like a safe bet, right? No, it's not. let me come back to that slide for a moment, and unfortunately I'm going to have to jump through the animation really quickly. Electron uses Chromium. Electron uses because Electron uses Chromium, it uses Ffmpeg. Because Electron uses Chromium, it uses Freetype. It has libuv. It has OpenSSL in it. And they don't document any of those vulnerabilities. So if your developer is looking at Electron and does a cursory security review and says, Electron has no CVEs, I'm good. No, they're not. Electron gets a little more complicated because they don't update Chromium very frequently. And so we'll talk about that a bit more in a couple minutes. But what I'm driving at here is your data from public sources is very limited. You cannot just rely on CVE counts to determine what open source you can use, and you need to help train your engineering organizations to understand that the impact of open source is more than just CVEs. If you go with I mentioned Ffmpeg openly acknowledges that they silently patch things. If you go to a paid data source like VulnDB, they actually analyze the code base and document silently patched vulnerabilities. So they've got over 1,200 Ffmpeg vulnerabilities. I mean, math's not that hard. I mean, it's basic counting, right? Well, what happens when your developer identifies a security bug in your application? You go fix it, and you don't CVE it. You just fix it and move on. And so do open source projects. Silent patching is not like a rarity that only some companies do. We all do it. You find a bug internally, you fix it, you move on, you don't document it. And that's also an issue for open source. Standard business practice. So now you've got all these vulnerabilities in the open source software. You've got open source subdependencies. And you've got applications that in some cases use hundreds of open source components. And they all patch on different cycles, and they all have different numbers of vulnerabilities. And so now your developers have to do an awful lot of patching. And how do they know what to patch when? GitHub recently rolled out update notifications. You receive an email when an open source library that you use is out of date. But what about your NuGet packages or your NPM packages or any of the other things that you use that aren't on GitHub? You have to go figure out what you need to update yourselves. So let's talk a little bit about what do we do? What does that roadmap look like? There's an awful lot of work to be done, and it can be overwhelming to know what to do first because vulnerabilities are everywhere. So since this is a little depressing, I threw in a little funny thing because this doesn't fly. The bug wasn't ours. It was in a third-party component that we don't contribute to, but we just use it. You're not a developer? You're a host admin? We're fully patched on 100% of the systems we can see. Great. Wait, how many can't you see? That's the other thing. It's not just having an inventory of your source code and what's in your applications. It's what's running on your cloud machines. What are you running on bare metal, on IaaS, in PaaS, on the edge? You've got to be able to detect all of that stuff and not rely on an email to a human who's going to go look for it, but automate detection there. So the goal is to get to accountability, and accountability in the people who are creating the software and the applications and managing them, not on the end user who logged in at their desk that morning to do their work. So when it comes to consuming open source, there's a maturity model to follow. And frighteningly, a lot of companies are in stage one, which is casual chaos. They don't have an inventory of what they use or where it is. They react when Struts hits the news. They react when Heartbleed hits the news. They had no idea they even used OpenSSL necessarily or what version they were on until that happened. And so the press or security researchers who report, hey, you're using an outdated version of JBoss, are their notification system. Moving up to level 2 in the maturity model, requires significant technical investment. It is the biggest technical hurdle because this requires you to have an inventory of binaries, of packages, of components, of snippets. What if you grabbed a piece of an open source package? You can make this mind-numbingly complicated, and I would encourage you, start with something attainable. If all you can do is do a match on binaries, do it. If you can do a match on packages and you can identify what you've ingested, great, that's a start. Because you can't manage what you can't measure. You don't know what libraries you're using, so you don't know which ones are at the highest risk. So you've got to get that inventory. Not having an inventory of your open source will prevent you from achieving any of the higher levels. So nailing that is critical. You can work on level 3 while you're working on level 2. You don't have to finish 2 before you start 3 because level 3 is all about your security response processes. How do you take that inventory data and do something with it? How do you respond to it? Getting inventory is about get clean. Once you have it and you have a response process, now you're in level 4 where you're staying clean. You got the developer to ship with a current version that has no known vulnerabilities. But 6 months later, there's 5 CVEs in that. What's your process for keeping that clean? And if you really want to level up your game, you will have a freshness policy where regardless of CVEs, you are keeping your libraries updated because the worst thing, one of the worst engineering conversations I've ever had was with a dev manager where I said, you have to take this security update from this open source library. It's critical. It's being remotely exploited on competitors' platforms. And they said, but they were like 6 minor versions behind or something because there had been no security vulnerabilities. So they just hadn't updated. But in that time range, there were enough architectural changes that it was brutal for them to upgrade. They had to make massive investments. So if they had been updating incrementally throughout, not only would they have picked up the silently fixed security issues, but they wouldn't have had the architectural investment to finally clean up that really critical, time-sensitive vulnerability. So there are other aspects, of course, curating your open source catalog, having a metadata service where you're pushing actionable information to the developers so they're not installing software that is not recommended. But this is a roadmap that can help get started. So a lot of what comes out of security response centers is all about patching. But open source security starts long before that. Before you implement open source, you need to do a security assessment of it. Are you going to let me check code into your application? No, I don't work for you. I'm some random person. You don't even know if I'm a good developer. But if I tell you my code's out on GitHub and 5 other people have installed it, oh, okay, well, sure, install it then. I'm sure it compiles. It'll be fine. You would not let your new hire just check in code to your critical applications. Don't let a stranger on the internet check in code. Do an assessment, upstream fixes, report vulnerabilities, determine should we even use this library. So for example, what we talked about earlier with Electron and how they don't document vulnerabilities. They look really good on the surface because they don't have vulnerabilities. But when you peel back a layer and you read their security documentation, they talk about how they're rendering untrusted content. Okay. And also, they don't really update Chromium all that often. If you go to the Electron page, and you might be familiar with Electron if you use Slack, because Slack is an Electron app, so is Skype. And we all had to take an update recently to Electron because of a remote code execution vulnerability. But the most current stable build of Electron is still running on a version of Chromium that's in the high 50s. Chromium 64 just released on stable build. And so do you really want to have dependencies on Electron? And if you do, can you afford to be on their stable build? At Microsoft, we've decided that we can't afford to have our Chromium in Electron apps be that far out of date. So we're very actively contributing to the development branches of Electron. And if you look in the 1.8.2 beta branch, you'll see they're up to Chromium 61, I believe. And the Skype developers are actively contributing to that because we want to have a version of Electron that is more current than 58. And that's one of the responsibilities of open source. If you're not going to actively maintain and contribute to it, it might not be a great idea for you to use it, especially if it's a risky application that could open you up to a lot of vulnerabilities. So unfortunately, the answer to that is yes. Library quality is based on vulnerabilities and number of updates and their security model. Some open source software has been completely abandoned. If you use open source that's been abandoned by the original writers, guess what? You're the maintainer now. You have a private fork of that. And no one else is going to be updating that for you. So all of these are things to consider with open source. Just because someone else wrote it doesn't mean you don't have to spend just as much time, if not more, securing it than you do your own native code. So how does the vulnerability management process work? When it's native code, you identify the issue, you assess it, dev and test to fix, you release it, Patch Tuesday, and then you have post-release support. But in open source, it looks like this. Freetype identifies an issue, and they assess it, and they dev and test to fix, and they release it. And when they release it, now Chromium can pick it up. And Chromium will dev and test to fix and release it. And when Chromium releases, now Electron can, I mean, we've talked about they don't, but they could take the new version of Chromium and update that. And then you can do something about it, whether it's Slack or just whatever application you use that's running Electron. How long are you waiting for that Freetype fix? This is the reality of open source security. So some developers say, well, let's just point fix that Freetype vulnerability and then we don't have to wait for Chromium or Electron. Okay, but you've just forked the branch. So if you've point fixed, you should upstream the fix and be a good open source community member. But you also need a plan to rebase back to master. Otherwise, you're constantly going to be cherry picking fixes and missing out on the major feature improvements. And again, you could come to that point in the road where you have to rebase, but you've got architectural changes at this point. So unless you're really ready to commit to maintaining a private branch, it's better to upstream the fix and then rebase to master. And as I've said, or at least implied, beyond upstreaming fixes, contribute to the code base. Don't just consume. That is the most important lesson I think I could give you is you could have a great assessment of zlib and toss a whole bunch of vulnerabilities over the wall to those maintainers. But I don't think the problem is actually finding more vulnerabilities. It's fixing them. So upstream some fixes while you're at it. You found the vulnerability. The code is all open. Suggest how it might be better. That might even speed up the amount of time it takes to get the fix. So the summary of my takeaways, and then I'd love to have some discussion with folks. Automate everything you can. Automate detection of what's in your source code. Automate notifications when something is out of date to the developer, and go where they are. If they're using GitHub, send a notification that way. If they're using Jira, automate the work item and do it in their systems. Don't just put it in email. That's the lazy notification, and that's how people miss things that were actually actionable, and you create a lot of decision fatigue. Also, if you automate the work items, you can start creating dashboards. And I know developers aren't big fans of dashboards, but development managers are. And development managers are who decide where the resources go for features and security fixes. And if you can make it really clear to them that there's a whole lot of security debt in their open source, that tells them where they need to apply resources. You can even go so far as to automate build enforcement of your security policies. You could, after an amnesty period or on test build systems, you've been notified, hey, you just built in a test system, you're using an out-of-date application, an out-of-date component. You will not be able to push to prod with this. And then if they try to push to prod with it, break the build. You can automate that. That's a cultural issue more than a technical one in most businesses. You can automate package updating. Check out Greenkeeper. It's an interesting open source application where you're using an open source library, it detects the new versions available, it will fork your branch, rebuild it with the new version, and if there's no breaks, it'll notify you, hey, you seem to be good to go with the new version. That's another area where there could be a lot of benefit from research and development to make that maintenance a lot faster for folks. But again, automate, automate, automate. Don't hire an army of people to do with Excel spreadsheets and email what you can do in systems. Complete a security assessment of open source components prior to use and recognize that just because it was approved once does not mean it is approved forever. These things get old and crusty, and it'll have to be updated on a regular basis. If you have an inventory, you'll know what libraries and components are the most important and the most widely used in your company. Focus on those first, obviously. And routinely update your components to current version, even if there aren't CVEs, because there's stuff in there getting fixed, you just don't know it. So, and again, that whole OSS community thing, actively develop on those branches. Be working on beta branches before they go stable so that you're ready to make the move once they are stable. Again, open source has been viewed as this free puppy. Yay, I have free code and it let me go faster. But puppies have to be maintained. You have to know where they are and what they're doing, and when did you feed them last, and have you taken them out lately? And they will always be like that. They never grow up. Like even a full-grown dog has to be fed, has to be taken to the vet, has to be put through dog training, and you always have that responsibility, and open source is no different. So you may as well do some active development in that space and make it better, not just for your users, but all the users of that library. So thank you for attending. I think I may have wrapped up a little early, so have some chocolate, ask some questions, have some conversation.
I have a first question, actually. As we saw most recently with the Spectre and Meltdown vulnerability issue, most of the people that were affected by that, including your employer, were told about it 6 to 8 months before the public was made aware of the vulnerability. So we saw a lot of collaboration between teams trying to fix a vulnerability. And so when you look at your slide where you sort of have a waterfall of vulnerability runoff, right? I don't know what you want to call that.
Hell?
Sure, yeah, hell. Do you think that like setting up more teams for collaboration will kind of make that a thing of the past, where you start to not only to say, hey, I rely on this, but in the act of, as you say, publishing fixes back to them, you start to create a collaborative working group that goes, hey, when you find out about something before everybody else does, can you please include me so that I can start patching?
So what's interesting about, I love the question because it's basically how open source is designed. Everyone can see the code. So yes, absolutely, we should all be collaborating. Now, if I'm publishing open source on the internet, I don't know that you've consumed it. I don't have a customer database, so I don't know necessarily to reach out to you and say, hey, we're working on a security fix. Now, some of the larger projects do have security groups, like the WebKit security group, where if you're using WebKit and you're going to actively be contributing, you can apply to join the WebKit security group and be a part of that interaction. But for a project like Freetype or Electron, go take a look at the code and start participating in that community. I think that what happened, and I'm hedging my words here, what happened with the Spectre vulnerability, where we have companies collaborating, we want that. We have the ability today with open source, we're just not leveraging it yet. So let's get to that point.
Great talk, and I wanted to ask at the end, you talked about some of the things to do about assessing the open source software, contributing, keeping track of it, updating regularly. Do you have any rules of thumb for time allocation? You know, per open source project, spend a day on assessing, plan to spend 1-2 developer hours per month per project?
Well, the challenge is that within one company, there's frequently multiple teams using the same component, and so they decentralize everything, which costs more than if they centralized.
I have no idea what you're talking about.
Go figure. And so if you've got, I mean, sometimes within the same project, multiple developers will use different copies of the same open source library, where all of a sudden you run an inventory and you find 19 versions or 19 separate copies of zlib in 7 different versions. You know, oh my God! Like, we have to maintain all of it. And what's worse, the developers, what they get bent out of shape about is that's totally ruining our build time. We're so redundant and have a lot of risk. So it's hard to say without knowing your inventory and how many things there are. Generally speaking, a basic assessment is probably going to take an hour if all you're doing is looking at what is their security model and their CVEs, and can we use that? Maybe 2 hours. But if you're going to really do an assessment where you're looking through the code and you're maybe running some analysis tools, it'll obviously take longer. And again, that's where the inventory comes in so valuably, because if you take your top 50 program or applications or components and really put it through heavy inspection, and then everything else is long tail, you're going to do a basic review. That helps you load balance a lot. And if you've got multiple teams using a component, you can share that cost. Like, I'll take zlib, you take libuv, and we'll share our results when we're done. I will say, a lot of companies who use open source have invested heavily in IP compliance and IP scanning, but not in security scanning. And so I would say take a look at how much you're spending on the IP compliance side of things and expect to spend at least as much on the security piece of it.
Very cool.
Hi, I just wanted to agree 100% with the problem space and generally make the comment that the automation doesn't have to be all, handcrafted. There are, vendor products out there that'll fail a Jenkins pipeline if you try to link against a vulnerable jar or something like that. And, granted, throwing security product at your org is not always the right answer, but the solutions generally fit in, the CI/CD delivery pipeline. And if you can stop things in the delivery pipeline before you get to deployment to the fleet, then, hey, you've prevented a headache, at least at one part of the problem stream. Second thing, it seems like an interesting research problem to leverage the social graph of open source itself to, more fully articulate the problem of the embedded componentry and, really surfacing the visibility of what things you need to worry about boxing off versus fixing.
Exactly, because if you can sandbox something, for example, when I was at BlackBerry, we sandboxed the WebKit browser in a specific part of memory, so a WebKit vulnerability wouldn't root the device. So even if it was a WebKit CVSS 10.0, it was probably just a 6.8 on our handheld. But that took some conscious effort in the security design. And so absolutely, you're right. And when you talk about different tools, I try not to mention tools, partly because I would have to update the slides every time I give this talk, because companies keep acquiring each other. And so, like, there's Flexera, but they're also Palamida, and then Protocode, but I think they might have been bought by one of them. And then there's Black Duck, but maybe Black Duck, I don't know where Black Duck is now. And then there's White Source. So there's a lot of different companies that'll do scanning. And what's interesting is at a company the size of Microsoft, different engineering groups, based on their different environments, like different tools. We don't even have like one tool to rule them all. We've got different things for different environments. And then we also have some homegrown things that suit our needs. But yeah, this is another area where there's great opportunity for discussion in the community about here's what I use and why and what it did well for me. Even because no one wants to give the critical feedback. That's always risky to be like, I hate this tool. It's a piece of garbage. It did this, this, and this wrong. That's always the bar conversation at like LobbyCon. But if you're going to go out and like write a blog post about why you like a tool and share that with other people and have a realistic conversation about, wow, that definitely isn't going to work for your environment, but it's great for mine, that would help everybody.
Any other questions?
Any thoughts on, I guess, the business impacts? I think it's frequent for security people to forget that security often exists to support the business. So if the requirements outweigh the required resources and impact for reviewing an open source project outweigh responding to a breach, then it may not make sense. And if anyone has done any type of correlation between the two.
I have not seen correlation between the two. One of the biggest challenges that I think we have in the field of security is that we are all driven by sticks and not carrots. We are not making it easier for developers to do the right thing. We're just threatening them if they don't. And so a lot of managing open source effectively comes down to creating the developer experience, not the security response experience, but saying, you know what, when the developer goes to NPM and they look up Moment because somebody tweeted about this cool package and they want to see about using it in their dev environment to accomplish something, you could have, through a browser extension or through, if you have a centralized source repo where people go to get their source code, you can push information to them about the health of that package, where this package has X number of vulnerabilities per year. It updates Y number of times per year. It is or is not recommended by your security team. Here are alternate packages that are recommended. Or, hey, the version you're looking at is not the most current version. Look at this version. And so you can push that information to the developer and make it really easy for them to just start from the right place. For example, I've seen organizations where every time you deploy open source, you have to have it scanned and approved for IP compliance. You have to register it. Well, the problem is I installed version X and now version Y came out and I have to go through this process again. The people responsible for the scanning and approval of the registration, if I know you use a library and a new version is out, why don't I just do the work I know needs to be done and then contact you to say, hey, new version is out and you're pre-approved to install it because I already did what you need done. And that's the pivot that we need to go to, not there's a new version out, you should request to use it, but there's a new version out and I know you need to request to use it, so here I did the work for you. And that's the move we need to make, is shifting around to how do we make this easy for developers, because then they'll just do the right thing.
Yeah, I think
It's also really important to come at this from both a grassroots and an executive point of view. And that's why I mentioned those dashboards. Being able to show a security maturity model, developers don't care about that. But if you go into your executive leadership team and say, we're in casual chaos, are we okay with that? Because if not, here's what we need to move the ball downfield. Then they can make that decision of, yeah, we're going to resource this. So.
I think maybe for the group, a couple of years ago, I was doing IR for one company. They had no security protection whatsoever. And the CEO said, I can spend unlimited number of funds for 10 years and deal with the breach. Or I can spend nothing on security and spend $2 million doing IR one time. And so their risk acceptance was set $5 million off to the side, and we're going to use it once every 5 years. And otherwise, we're not going to play the security whack-a-mole game. And a lot of people in security don't see that because they forget that they are there to support some business mission. But I think you have a really good answer.
Well, and I think the challenge in that scenario, first off, oh God, it's terrifying because what about the breaches you didn't know you had to remediate, like the ones that didn't hit the news? Like, it's sort of the, sir, we have a mouse problem. They're stealing cheese. Well, how much cheese? Can we just make more cheese? Do we really need to do anything about the mice? And it's like, yeah, we do. And so having that sort of environment, I don't know what to tell you. I feel like I should buy you a drink or buy myself a drink or something because that's crazy.
I think the Target compromise was a good example because it's all money driven, right? If you lose PII, yeah, there's reporting requirements, and it could be an impact that dissolves your business. But we haven't seen that case. Target did a good job of recovering funds wherever they could. They sued the compliance auditors, they sued security vendors, they sued everyone to recover funds, and Target's doing fine. So if they doubled their security controls and their security investment, chances are they may still be breached, but they'll recover from it. Mm-hmm. So it's really a balance on what supports the business rather than a lot of people in this room just see security.
Right. And I mean, I think that for a lot of executives, they're weighing brand damage. It depends on what industry you're in. If your software is used in cars, okay, that might be a little different. So you're right.
Just to add to what Kim said to that comment, I think we're seeing a big shift between software companies and non-software companies. The companies that are producing software today, more and more are doing things in security because otherwise that's now a buying criteria. It's an acquisition criteria. And if you're not making these investments, it becomes harder to answer these sorts of questions. You know, we all send each other these SOC 2 questionnaires and say, hey, what are you doing about security? And so these things that you're talking about are getting built in. They're getting built into regulation. And so, yes, Target may be able to get away with it and say, we're not a software company, but now every company is a software company and every company is a supplier and a consumer. And so we have to go to the, how do we make it feasible? How do we make it constrained? How do we show effectiveness?
Well, and how do we anticipate the direction compliance is going in, where governments are starting to ask for a bill of materials in your software to understand how your developers have been trained to manage open source and what's your update strategy? And we're seeing that coming from governments to software development houses, but also we're seeing a lot of pressure coming from legislative bodies towards IoT and wanting IoT to list their bill of materials, what's in this. My argument is I don't actually care that I don't need to know what's in it if I can't update it. I want to know that Nest or Dropcam or whatever device, the internet-enabled crock pot, because, oh God, I have to change the pot roast temperature right now. I need to know that there's an update mechanism for those things to get updated. I don't care if it's Freetype. I don't care if it's libpng. So there's been a lot of movement in governments internationally and here in the U.S. trying to ensure software developers have a better handle of what's in their software. So, all right.
Thank you very much. What a great talk.
Thank you. And please have some chocolate. They're good.